Unit 1, the alphabet and grammar of geometry. Preview video 1.1, the language of geometry. Pause for a moment. Ready? Through your nose. Inhale. Hold your breath. Exhale 5. Inhale through your nose. Hold your breath. Exhale slowly 5. With your eyes closed, just sit there quietly for a few beats. Deep breath. Alrighty. Don't forget to have your preview notes on hand, which is this physical packet. I also recommend multiple colors. One of my top 3 favorite lessons, top 3, I won't rank them in order, but this is one of my top 3. Why? Because I am introducing you to a new language, believe it or not. Mathematics is a different language. Some of you might have figured out why it seems a little difficult because your brain's actually learning another language. But geometry is a very specific type of mathematical language, and it's very different from previous math classes. Don't forget date, time, location, as well as a parent sign off. Please, I beg you, turn off all digital distractions. If your personal addiction is not listed there, still turn it off. Be focused only on this activity, listening, watching, and writing. Here we go. The language of geometry. Keywords. Point, line, ray, angle, plane, dimensions. Geometry. The English language consists of 26 letters. Geometry only consists of 5. But before we talk about those letters of geometry, we first need to refer to something called dimensions. We live in a world of 3 dimensions, length, width, height. Basically, anything you can stick your physical hand on has dimensions of length, width, and height. The 4th dimension in physics is considered time. So you might say, since we live inside time, we live in 4 dimensions. The first dimension is length. So if I were to say I walked from San Jose to San Francisco, and the distance I walked, that concept of distance is only 1 dimension. And when we work in things with only 1 dimension, we use what are called singular units, such as inches, centimeters, feet, meters. The second dimension is things that have length and width. So if you were painting a wall, that would be 2 dimensions, length and width. Think of, if you were painting a wall, just kind of scrubbling a wall there, that is the concept of area. And for 2 dimensions, we use inches squared, centimeters squared, feet squared, meters squared. Things that have length, width, and height anything you can physically get your hands on per se, like my teacup, that is 3 dimensions. And when we're talking about 3-dimensional measurement, we use inches cubed, centimeters cubed, etc. The dimensions impact the exponents. Technically, this is inch to the first dimension because it's the first. We usually don't include it. Here are your geometry letters. Point. A point is a point. Ta-da! Congratulations. You've drawn a point. You may call it a dot. Okay, like, something .com, but it's not a decimal point. It's just a point. It's a marker in a positional space. So if I were to ask you to draw a point R, it would be like this, point, and we label all points. This is important in geometry. Geometry is a language. And just like you have specific notations in languages, such as in Spanish, the difference between en and enya, that notation makes a difference. In geometry, we use capital letters for points. So I would call this point R, capital letter. Ta-da! Point R. A line. Notice the double arrows. The double arrows means, in theory, that line goes on to infinity both directions, on to infinity both directions. I were to ask you to draw a line, EF, it would look like this. EF line, doesn't matter which way it tilts. That would be line EF. Notice the capital letters means there's 2 points on that line. I can call the same line FE. Totally legit. Both ways. I can go both ways because I have an arrow going both directions. Now, just to make life interesting, what if I had 3 points on a line? Say, I don't know, J. We only use 2 points to name a line because that is the definition of a line. It's a minimal of 2 points. Minimal of 2 points. So this entire line conceptually can be named with only these 2 letters, EF, arrow above it, little baby notation. I could call it JF if I wanted to. It's the exact same line because it goes on forever. I could call it JE if I want to. Again, notice the arrows and the capital letters. So for a line, you can switch the directions because of the double arrow both ways. Now, another way we name lines in geometry, same line, let's say I had an E and an F, but I just want to name the entire line. For speed's sake, I can use a lowercase cursive letter at either end. For example, I could call this entire line, line Q. Notice it's a cursive letter and it could be either on the right or the left. Cursive lowercase. You're like, Miss Way, I don't know my cursive letters. Learn them. Cursive or italic, if you will. But the cursive lowercase names the entire line. So far, we have 2 of our 5 letters, point and line. A segment is simply a piece of a line. So like this, ta-da, you have a segment. It's you take a line and you just chop off and you're just getting from here to here only. That's a segment. So if I were to draw a segment HJ, you're like, but Miss Way, H is on the left. Not necessarily. HJ, the direction's interchangeable. I could call this same segment JH if I wanted to, but again, capital letters. So JH, HJ, guess what? Same segment. Why can we switch it up? Because it's the same both directions. Oops. Array, careful. It's not the same both directions. Array is where you take a line, but it only goes one direction. So you have an endpoint and an infinity arrow. That's array. We name rays by their endpoint, and direction doesn't matter. That's array. It's also array. But for the notation of array, this first letter is always the end point. The second letter is towards the arrow. So watch the difference. If I want to draw array PQ, P must be my endpoint. P is my endpoint. The direction of the ray doesn't matter. But Q is my arrow point. Look carefully, draw array QP. Order does make a difference here. Now, Q is my end point. P is my arrow point. Order matters here because it's not the same both directions. Now we've gotten 3 letters: point, line, segment, ray. That's 4 letters now. Here's our last one, a plane. Think plane, think tabletop. Just kind of shade it. But even though you are seeing a 4-sided quadrilateral, just kind of shade that, trace it. The example of a plane. Realize you only need a minimal of 3 points to name a plane. So all shapes, and the most elemental of shapes, which we will camp out nearly 2 months on, all triangles are planes. Pentagons are planes, hexagons are planes, rectangles are planes. A decagon is a plane, a dodecagon is a plane. That's a 12-sided shape. All of those are planes. So even though I say the word plane and you most likely think of a quadrilateral tabletop, any geometric shape is a plane. There's a couple really important things you need to know about labeling planes. If I say draw a plane, EFGH, it's important when you are labeling E, F, G, and H that you either go clockwise or counterclockwise. You never zigzag. So what I'm about to do is wrong. Do not copy. E, F, G, H. What I just did was incorrect. Let me show you why. I did zigzag labeling. Watch, trace with your finger, just trace, not with your pencil. Finger, finger. E, F, G, H. Notice the zigzag. That's incorrect. Now start following me. The correct way to label this, I could label it like this: E going clockwise, F, G, H, or just add another layer here so you can see both. I could have labeled it counterclockwise, E, F, G, H, this way. Clockwise, counterclockwise. Both work. What does not work is zigzag. Now, I could also name a plane by a single capital cursive letter. It's cursive or italics. In the upper right-hand corner, it's italics, so it's not mixed up with a point. I could name this entire point R or T or F or a single letter, that it has to be cursive and it has to be in the specifically the upper right hand corner. gonna draw a plane, H-I-J-K. You artist folks are going to be drawing this a lot prettier than I am. And it's going to intersect another plane, JKLM. H-I-J-K intersecting JKLM. Did you hear letters repeated? That's important. If you have in a single description the same letters, they are the same point. Same letter, same point. Same letter, same point. So when I say H-I-J-K, and then I have another plane, JKLM, it's the same JK because it's the same diagram, same letter, same point. So intersecting another plane, JKLM, would look like this, J to K, and oh, wacky, we're going into 3D, friends. JK, counterclockwise, LM. That is an example of my plane. I'm going to shade it. H-I-J-K, intersecting the two-dimensional JKLM, intersecting at that segment. There's your letters. Here's some more grammar terms, how things put together. Collinear, on the same line. In this case, we would say points E, F, and G are collinear because they're on the same line. Let's just give this a name, P. Coplanar, on the same plane, E, F, G, H, are non-collinear, not on the same line, but they are coplanar. They are on the same plane. Now, before we go into actually making geometric words, which is a combination of these letters, which we call geometric diagrams, I need to teach you how to read. Guess what, my friends? You don't know how to read. Yeah, you thought you learned to read. This is an absolute essential skill that I will enforce dutifully in this class. And the skill is this. I'm going to teach you how to read. You don't know how to read. In this math class, you're not simply going to look with your eyeballs, but you are going to learn to read with 3 body parts 3 times. Go like this with your fingers. Say this after me. Say 3 body parts 3 times. Do it again. Read 3 body parts 3 times. Now say it as a promise. I will read with 3 body parts 3 times. Say it with me. Fingers up. I will read with 3 body parts 3 times. Yes. So 3 body parts 3 times. Let me show you what I mean by this. This is literally the one skill you get out of my class with consistently. I will be ecstatic. So skill number 1, the first time you read with your finger on the paper. That's 1 body part. Eyes looking. That's your second body part. Lips moving and making sound. On a test, your lips will still move, you just won't make sound. That's pass number 1. Number 2, 3 times. You go back and you filter by underlining or highlighting keywords or phrases. Pass number 3, you cross out the key words, the key parts, as you account for them in a diagram or labeling a diagram. I'm going to model this for you a couple times. So you need a highlighter and a pen of sorts. All right. So turn your page until you see this. I'm going to model what 3 body parts 3 times looks like for you, that you will follow both in class and at home when you are all by your lonesome. Finger, not pencil. On the page, ready? Aloud, read with me. You're like, Miss Way, what happened to the sound? You should have been providing the sound. You should have been reading out loud. You should have heard this coming out of your own lips. On plane H, draw coplanar line PR with collinear Q between points P and R. Then draw coplanar ray PT and a ray MQ. Read, finger on paper, lips moving. That's number 1. Pass number 2. You are reading quickly now and either underlining or highlighting keywords. So on a plane, I got a plane here. H, draw a coplanar and it's a line with a collinear point Q and it's between the points. Draw a coplanar, it's a ray and another ray. So you're either underlining or if you prefer, you can have a highlighter, whatever strikes your fancy. This is called filtering. This is pass number 2. This helps your brain filter what's essential to diagramming. Now, very important. You draw, label, list, cross out. As you account for things on the drawing, you cross it out in the original description. So, for example, draw a plane H. Notice cursive uppercase. Drawing a tabletop. It's cursive. So italics, cursive, however, and it's uppercase, it's in the upper right-hand corner, it names the whole line. Draw a coplanar line, that means so it's on the plane, so imagine it on the tabletop. So I've got a line here, it's on the tabletop, PR, those are capital letters because they are points. As you account for stuff in the diagram, you should cross it out. I have a plane, I have a coplanar line. With a collinear, that means on the same line, Q, between points P and R, between, cross it out, it's between. Now, it didn't say exactly in the middle, so I offset it. Don't ever put anything exactly in the middle unless you're told it's the middle point. Took care of that. Then draw a coplanar ray PT. Same letter, same point. You don't add a second P, same letter, same point. Notice P's the end point. So a ray starting at P, going towards a T. That would be ray PT, and it's coplanar, which means it's on the plane, and a ray MQ. You're like, okay, same letter, same point, so it's the same Q, but Q's not the end point, M is, so I'm introducing another point M. endpoint M going through Q. Q's the arrow point. 3 body parts you read with, 3 times you read it through. Congratulations, you now have your first geometric word diagram sentence. Let's try another one. This one, you're going to pause the video and do by yourself. Pause. Welcome back. You should have a red pen in hand. Let's see how you did. Pass number 1. Draw a plane EFGH intersecting plane FGJK at segment FG. Draw in a plane HGJT. Points FWXJ are collinear on line Q, which is also coplanar with plane FGJK. Wowzer, that's a lot of words. That's why you should have filtered. So filtering. I have one plane, EFGH. I have a secondary plane, completely distinct, FGJK. Same letter, same point. Look very carefully. What are the same letters and the same point? I see a G, I see a G, and I see an F, and I see an F. Notice that carries over. At segment FG. Draw in plane. There's another plane, HGJT. Points FWXJ are all collinear on a line Q, which is coplanar with the plane. Same plane as this, right there. They're collinear on line Q, which is also coplanar. That's pass number 2, filtering. Draw a label list, cross out. So I have EFGH. Now, where you start your EFGH doesn't matter. What does matter is you go clockwise or counterclockwise. So I'm going to go like this. E, go counterclockwise, F, G, H. I went counterclockwise. Intersecting a plane F, G, J, K at FG. Because I know I have 3 planes, I automatically know I must go into 3D. 3 planes, 3D. So I'm going to make it look FG, like we're going into a box. FG, I have to go now counterclockwise, JK. At segment FG. Notice they intersect at FG. Draw in plane HGJT. Same letter, same point, same letter. HGJ. Now you can see why you needed to draw into 3D and not flat. HGJ. Oh, T. There it is. Points F, there's F, W, new point, X, new point, J, O, same point, are collinear on line Q, which is coplanar with this plane F, G, J, K. So on this plane, I am now drawing a line Q, cursive, lowercase, and I have F, J, W, X, which are both collinear on line Q and coplanar. Ta-da! You made all kinds of mistakes. I really hope you made all kinds of mistakes. So what I recommend is that you write yourself a little note. What do you want to remember? And you should be writing yourself a little note in red pen. Let's try another one. Next page, 26. The English alphabet consists of 26 letters. Geometry alphabet consists of only 5. When you put these letters together, you get a word, quote unquote, word. Our first word is going to be the angle. An angle consists of 2 rays hinged at a common endpoint. So an angle looks like this. 1 ray and another ray hinged at a common, which means same endpoint. Ta-da! You have an angle. So we're going to draw an angle, EFG. Very important. When you draw an angle, we're going to use 3 letters, and this middle letter is the elbow of an angle. It's the elbow, the hinge, the common endpoint, specifically called a vertex. So angle, 2 rays, common endpoint. F must be the middle because F is the hinge. And where the E and G goes, it does not matter. But F is what we call the vertex. So we can label this angle EFG. Trace with me, EFG. Or now start at G and go this way. Start at G, pencil on G, GFE. We could name this exact same angle GFE. Doesn't matter, but what's common is that F is the vertex. It's the hinge. It's in the middle. Or just to make things interesting, if I have a very complex diagram, I can add a number in the mouth of the angle, and I can name it by that singular number. So I can call this angle 1 if I wanted to. Turn the page. You're looking at this page now. Because I have multiple colors, I'm going to come back to this. So right here, when you are working with angles, it is always important that you trace and sweep the angle. Trace and sweep. I'm going to show you this twice, both on the screen as well as in real time. Follow with me. We're going to trace and sweep angle ACD. Let me get my color straight here. ACD. So that angle would be like this. ACD. Trace and sweep. That angle right there would be angle ACD. Let me show it to you in real time. Same thing. Angle A, trace and CD, trace and sweep. That is angle ACD. Let's try another one. Trace and sweep angle DAB. So you start at D, go to A, go to B, trace and sweep. That would be this angle. You always sweep at the elbow of the angle. In real time, same angle. DAB goes like this. Start at D, go to A, go to B, and you sweep at the elbow. Trace and sweep. Sweep at the elbow of the angle. So angle DAB would be this angle right here. Angle ACD would be this angle right here. Now we're going to trace and sweep FCE. Starting at F. Go to CE, FCE, trace and sweep. That would be that angle right there. Taking a look in real time. F, C, E, trace and sweep at the elbow. You sweep at the elbow. It'd be like this, like shoulder, elbow, wrist. F, C, E. You sweep at the elbow. The last one, D, G, E, would be this angle. You start at D, go to G, E, trace and sweep at the elbow. It'd be right there. Taking a look here, D, G, E, this angle would be like this. Starting at D, go to G, go to E, trace and sweep at the elbow. Elbow. D, G, E. Shoulder, elbow, wrist. You sweep at the elbow. Now we're going to do a couple diagrams using this. Now we're wondering, why is it important to be able to go from hearing and seeing and drawing? And the reason why it's going to be very important, and the reason why at this particular moment, this may seem a little like challenging, is because both spoken and written language is predominantly a left hemisphere part of your brain, left hemisphere, speech language. So reading, speaking, I say predominantly, it's not 100%, but it's majority is predominantly what we call left hemisphere brain. I'm sure you've heard of left and right hemisphere. But guess what? Drawing, visual, spatial, conceptualizing things in 3 dimensions, like a plane and then a line on a plane versus going through a plane. All of that is right brain. So all of this speaking, going to a drawing, reading, going to a drawing, the reason why it feels challenging is because we are engaging simply more brain cells, both the left and right hemisphere simultaneously, which your brain uses both pretty much all the time, but maybe you're not used to doing it in math. So your brain halves are talking to each other in a greater way than they normally would be in a math class. So learning how to visualize written and spoken words and using language to describe the pictorial, visual world around you will be key skills. Key skills, learning to do this will be key skills, going back and forth from spoken, written language into the visualization, back and forth. So let's do another one. Do 2 more and we'll be done. You are now looking at this page. 3 body parts, 3 times. Finger, not pencil, finger, please, right here. Reading aloud with me. On plane WXYZ, draw a segment EF. On plane WXYZ, intersecting a line BC at point H. Trace and sweep angle BHE. Ready? Pass number 2, filter. Draw a plane. WXYZ. Draw a segment on the plane. On, that means it's coplanar. Intersecting a line, BC, at a point H. Trace and sweep the angle, BHE. So one step at a time here. I'm going to draw a plane, 4 letters. Tabletop. If you're left-handed, it might be easier to tilt it the other way. Just, I'm drawing as a right-handed person. If you're a left-handed person, tilting your planes towards the left might feel more natural to you. It really doesn't matter. Okay, so don't think you have to tilt it to the right. If you're left-handed, you can tilt it to the left. WXYZ. So I'm going to start my W here, and I'm going to go counterclockwise. WXYZ. Got that. Draw a segment EF on the plane. So EF is on the plane. Doesn't matter which way I tilt that segment. But we're intersecting another line, BC. That's a segment. This is a line. So a line must have arrows, B, C, and they intersect at point H. Trace and sweep, BHE. Watch, B, H, E, trace and sweep. I'll do it again, BHE, BHE, trace and sweep. I'm going to shade it just for extra measure. There you go. You sweep at the elbow of the angle. Ready? Try this one completely on your own. Ready? Pause the video. Welcome back. You should have a red pen ready to correct. I'm just going to very quickly draw it. You should have a cursive Q in the corner. So some of you might not remember. I'll take an italics Q, if you will. Technically, your cursive Q looks like this. Okay, but so I'll do an italics Q, since that's what most of you are familiar with a coplanar line AB. Coplanar segment JK. Intersecting AB at R, and it's a segment. Doesn't matter what switch is, that's fine. At point R. Trace and sweep KRB. KRB, trace and sweep. So you should have swept right there. Write yourself a note in red pen. What did you do right? If you did it right, big star smiley. Woohoo, I'm so amazing. If you did something incorrect, totally fine, but write yourself a note. What are you going to remember next time? Here you go, friends. Summarize. What are the key concepts you learned today?